Okay, we have 3 absolute value of x minus 5 plus 1. And this time we're going to equal it to 6x minus 2. And I'm still going to follow my same general steps. I have an absolute value, and so I'm going to isolate it, okay, before I interpret the question. I'm going to isolate. In order to isolate, I'm going to minus 1 from both sides. Gonna divide by 3 on both sides. Can I have a brave volunteer to tell me how the other side of the equation simplifies? All right, Lori. 2x minus 1. Can somebody else tell me why she said 2x minus 1? Well, wait, we'll go in the back. Divide the 6 and the 3. Yes, awesome. Okay, stop and think. Okay, so right now I have the distance is 2x minus 1. Interesting. Can distance be 2x minus 1? Maybe. It kind of depends on what x equals, right? It depends sometimes. If I get the x's where this ends up being a positive result, then it will work. So the answer's maybe means you have to split and solve. We're not sure though. We don't know yet. Okay? So we have a maybe. It means split and solve. Okay, so when I split this apart, okay, I'm going to end up with negative. There's the negative side. Notice, okay, and then I get the positive side. The positive side is exactly the same. Notice how the negative is distributed to everything. Also, notice how when I split it, that's when the absolute value, whoosh, goes away because you've split it apart. All right, solve, split and solve. Do your PEMDAS, combine your terms, see what happens. I'm going to start by distributing my negative here. Yes?
So when you're splitting and solving, you never change the absolute value, right? You always use
Correct.
negative or
I always change the other side. Okay. I like to have positive x's. I would encourage you to combine your x's first before you start the other stuff. Okay, so I get x equals 2. Okay. Did I actually find answers? Maybe. Maybe. Split, solve, check. If you have a maybe, you're gonna have to check your work. Question?
So you would do PEMDAS for like, it doesn't matter if you do for x minus 5 equals negative 2x plus 1, it doesn't matter if you subtract for
Yeah, that's fine. I like to combine my x's first and then start trying to isolate it. Okay, so because we have a maybe, we have to check our work. Now, right now, the distance number is supposed to be 2x minus 1. Okay? We got a number of x equals 2. And so I'm going to go ahead and check what kind of distance do I get. Okay? 4. Can distance equal 4? Yes. Yes, it can. So right now my answer is yes, right? It was maybe. Maybe yes, maybe no. I mean 3. Yes, I mean 3. Thank you. Can distance equal 3? Yes. Okay. Check, check, check. It works out. Right? It's kind of like your thinking is delayed because you got to figure out what x is before you answer that question. All right, so I also have x equals negative 4. Thinking. Can it be negative 9? No. 2 is your only answer. It didn't work. Okay. So I'm going to give you a definition. Okay. Extraneous. Extra. I like the word extra. Extraneous solution is a solution that doesn't check. I'll spell that out. That does not check. Does not check. I checked it and it didn't work. You didn't mess up, guys. Your algebra was perfect. Okay? You've never had an extraneous solution until now because you never had an equation where that was something that could happen. Okay, so that is new this year. Your algebra, your PEMDAS was perfect, but you got an answer that did not check for a variety of reasons. Okay, this one is for reasonableness because distance had to be positive. Yeah.
Would the answer be undefined, or would you?
No, the answer is 2.
So you would just say x equals 2 and just ignore it.
Correct. You just cross it off and don't say anything.
But that would be called the extraneous.
Yes, if I asked you what was the extraneous solution, that's what you would say. Okay, here we go. Graph time. Yes. Oh. Okay, here we go. Just going to do it right here, right at the bottom of my paper. Okay. All right. This is going to be really cool. When you see it, don't say anything. Yeah. You need more graphs? I have more sheets up here. Okay. What I want you to do, notice how I'm doing y equals here? I want you to actually graph it. Okay. Okay. Graph those two things. And then just label the intersection. The intersection is where they overlap. Okay, look for any similarities, tricks, comparisons between what we did algebraically and what you see on the graph. Don't say it, just think about it. What do you see from what we did algebraically and what we did graphically? Is there anything you notice that could be useful to you? This one? Okay, so I went right 5 up 1. So right 5 up 1. It's opening up and my slope is 3. Does that answer your question? Yeah. Okay, yep. So this one is y equals mx plus b. So I did the intercept and the slope on that one. Okay. Look at the two things I highlighted. Look at the two numbers I highlighted. The solution is x equals -2. The intersection is 2, 10. Now notice that the blue piece here is actually the left side of the equation we started with, and the green piece is the right side of the equation that we just did, okay? Now, I only have x's, which means my answer is x's only. So when I get down here, I'm sort of like making it two-dimensional with x's and y's. X's and x's. Where do they overlap? At the point here, 2, 10. But because my question only has x's, the answer is x equals 2. Notice how the extraneous answer doesn't even appear on the graph. It's because graphs don't show you extraneous answers. That's why. Graphs don't show you extraneous answers. Okay, some of you are very visual people, and you can picture what the graph looks like to see which one of these might work. It doesn't matter how you check your work, as long as when you get a question that's a maybe, you do something to check it. Yes?
So you're saying the point of the graph is just another way to check it?
Yes. Yeah.
So you don't have to do that at all?
No, it's just a different method to visually see the solutions, okay? And I'm pretty sure that I can guess what these things look like in my head. And I'd be like, oh, I don't think -4 is going to work. Yeah.
On the Delta map that you posted for this,
That says solve graphically.
no. When you get an answer, can't you also check by plugging in the x to the equation and
Sure.
on both sides?
Yeah. It doesn't matter how you check your work as long as you go back and check it.
Okay.
Yes. Okay. Whoop. Here we go. I'm going to give you another question to try. You may graph it to check or not, but you've got to check it somehow. All right. Here you go. Absolute value x minus 4 plus 1 equals 2x minus 2. So I'm going to start, we isolate, you're going to think, and the answer is maybe. Okay, it's your choice how you check this, but I want to see you check it, either graphically or by plugging in. Okay, here we go. So as I isolate, my distance is 2x minus 3, so that's a maybe. So I'm going to split and solve because I can't check it until I have something to check. So one of these, okay, is going to be negative 2x minus 3, and the other is 2x minus 3. Okay, so we get x minus 4 equals. Okay, notice the side that's changing, not the absolute value piece, it's the other side. Okay, so start distributing and combining your like terms. I suggest strongly that you combine your x's first. Okay, so now I'm adding 4. Okay, 3x equals 7. Divide by 3. Yes, fractions are okay. 7/3. Okay. Other side. Minus x. Plus 3. Okay. So I have 2 x's. Now I have to check my work. So there's a couple questions here on how do you check your work. Okay. So I'm going to do it a couple different ways. everybody should have this amount of work. Okay? How you check it is up to you. So I'm going to do it the first way. I have my distance of 2x minus 3. Okay? And I'm going to try x equals 7/3, and I get 2 times 7/3 minus 3. So that's 14/3 minus 9/3, which is 5/3. Okay, so that's a yes. That works out. Okay, answer. Now I'm going to check x equals -1. 2 times -1 minus 3, so that's -5. That is extraneous. That doesn't work. Yes. Yeah. Yes. Okay, so this is me checking the reasonableness based on considering the distance to be 2x minus 3. Okay? Yes.
What if we do what if the problem has greater than or equal to?
That's what we're going to do next. We still are going to think about it and answer reasonably. Now, another way to check is, let's go back up here to the beginning, because I had some people ask about this. Okay? What if you just go up here and try the values? Now, I'm going to plug in -1 first because that's a lot easier. Okay, so absolute value, -1 minus 4. Okay. -5. Absolute value of -5 is 5, and I get 6 on this side, and then I get -2 minus 2. That does not work. That's why -1 it doesn't matter where you check it, it doesn't work. Okay, I saw your hand.
So you can't determine if 7/3 or -1 works by looking at it, right? You can't say -1 doesn't work, right? You've got to plug it in.
It's not because this is negative it doesn't work. It's because the outcome was negative. Yes. Here, Eve.
I'm kind of confused on how you checked it and why 5/3 is yes.
Okay, because 5/3 is the distance. Can distance be positive? Yes. Okay. You see here 2x minus 3. Can distance be negative?
What if it was positive?
Then there would be 2 yeses.
Okay.
That means you'd have 2 answers. You could cross off both of them, or you could say yes to both of them. Yeah.
If it were, like, say you plugged it back into, like, the original problem, if they were both, like, say it came out to being -4 is equal to -4, that would work, right?
Yeah, then you, it's yes.
Because then if you checked it, like, the other way.
No, you will get the exact same yeses and nos no matter where you check it, as long as you actually check it correctly without making arithmetic mistakes. Okay?
Yeah, no, so what I'm saying is, like, if you got, like, -4 equals -4, and then you plugged it in to, like, the original distance, so, like, 2x minus 3 or whatever, that would come out positive?
Yes. Yeah, it would. Correct. Yes. Eve. That's okay. All right. So now, I'll,
Yeah. Well,
Yep.
if they're both no, then what do you answer?
nothing. There's a little minus button, and it gives you the empty set.
Okay.
And then you just submit nothing.
Okay.
All right. I could graph this and end up with a solution. Okay. Just so you can see it, because we all have different strengths on how we see our problems. Okay, so I'm going to graph it really quick so that you can see that. Okay. Yep, this is just the second graph that you need. So I'm just going to go up here. Y equals x minus 4 plus 1. So that's going to be in blue. So that's right 4, up 1. Okay. this is the right side. This is the left side, right? Some of us are visual learners, and it makes sense when we check visually. Some of us are arithmetic checkers, and it makes sense when I plug it in and get a concrete yes or no. Some of us completely understand how I'm thinking about the distance. Okay? You got choices. It's up to you. Sydney, question.
So the slope would be 1 for x minus 4
Yes.
y, right?
So it's a V shape, and the slope is 1. Okay. You guys ready for your last bit of mind-blowing information?
Yes.
Guys, you're going to think all year in here, I promise. All year. Okay, but this one's fun. The negative sloped portion, look at the piece I highlighted. The negative sloped side is the one that has the intersection. What? Okay? The negative side is the one that actually came up with the solution. Okay? The positive sloped one didn't actually touch the green line. That's why it's extraneous. Extraneous things don't appear on the graph, but kind of crazily, wait for it. It's like hiding. Anyway, okay, I'm going to erase it because that is not something you need to know. But just look at the connections on where it checks and where it doesn't check and how you can use graphs to help you do that. Notice that the right side was the side that did not get a solution, and you can see how this is the piece that does not intersect. Okay? So, there you go. That is the end of your 2.3.